Que je vais pas tarder. So I think I'm gonna start this presentation. So to begin, so as you can see, I will talk in English. This is something that I want because I think DroidCon is an awesome event, and I want it to, to be reconducted next year. So I think talking in English is better for DroidCon because we can invite people from all around the world. So I'm going to start today talking about crafting custom Android views. So who am I? First, I wanted to thank DroidCon for inviting me and for organizing such a great event. So who am I? My name is Cyril Mottier. So you can find me on Twitter with @CyrilMottier. So why am I here? So basically, I'm a Android developer who is passionate about Android, of course. I spend a lot of time sharing on the internet, such as on Google+, Twitter, or on my personal blog that you can find at cyrilmottier.com. And this, being a passionate person, Google recently rewarded me as a Google developer expert. So I'm now a Google developer expert. So basically what I do is I do conferences like this one. But I'm not working for Google, so everything that I say is not, linked to Google. It's said by me and only me. So this is what I'm doing on my personal time, but professionally speaking, I'm working at Capitaine, as you can see on my T-shirt. No, there is no T-shirt for now, so we're still waiting for the new T-shirts. What is Capitaine Train? So Capitaine Train in French. Capitaine Train is selling train tickets, so if you don't know it, please go to capitainetrain.com and buy a train ticket, and you'll see that we are really great at doing, buying tickets. We want to make a revolution on how we buy tickets and use the train. And we are, if you are as passionate as me on train, you can apply to Capitaine Train because we are hiring lots of great engineers. So you can be an Android developer, an iOS developer, a core developer, everything. Just apply or talk to me after the conference. I'd be glad to talk to you. So I'm not here to talk about, I'm not here to talk about me or Capitaine Train. I'm here to talk about Android views. So, and more specifically, Android custom views. So in order to understand what a custom view is, I think it's necessary to first understand what a view is. So let me ask you a question. What a view is? Do you have an answer to that? No, nobody? Actually, it's quite difficult to have a great definition of it. If you go to the SDK documentation, you'll have this definition. A view is a basic building block for user interface components. So what does that mean? It basically means that a view is a basic component of a UI of a user interface. So for instance, a text, an image, and stuff like that. And if you dig in the Android SDK, you'll see a bunch of built-in SDK views, such as the text view, the view group, a view, a linear layout, a button. There's lots of views like that, so I won't give you the entire list because it's really huge. What's interesting here is to understand how they are organized in the SDK. And they are organized like this. First, you have a class, which is the view class. The view class extends from object, obviously, and but it extends directly from object, so it does not inherit from something else. And above this view, you have some other view, such as the image view, the text view, and let me ask you what an image view does. It displays an image, yes. What a text view does, it displays the text. So as you can see, an image view only displays one single thing, an image, and a text view only displays one single thing, a text view. Below that, sometimes you can find some views that inherits from views that inherits from view. So let me show you an example of that. For instance, button. Button extends text view, and actually buttons is a nice example because if you go to the Android source code, you'll see that button is probably the easiest source code to understand because it's only 10 lines of code. And do you know why? because actually button extends text view and add only one single behavior, which is the clickability, of course. So if you go to the button source code, you will only see that the class only called the super constructors, and in those constructors, they call set clickable to true. So you can basically do the exact same thing just by creating a text view and setting it clickable. And what's interesting in this architecture, in the class architecture, is the view group. And if you remember your university classes, you'll see the design pattern composite. So basically what we have here is we have a view group which extends a view, but it contains also some views. And those view groups are really different from image view and text view and stuff like that, because they are actually not built into to draw, they are built into layout other views. And below that, what we can find is, for instance, linear layout, frame layout, and relative layout. I think you all know all of them. So on this slide, as you can see, there is maybe a misspelling. Do you understand why linear layout is called a layout while its parent is a view group? No, you don't? Me neither. Actually, I think this is a problem because Android has been released in 1.0 quite rapidly, and they forgot to rename the class. This is my opinion. I don't know exactly why they decided to call it a view group, but decide to call children layouts, but basically a view group is a layout. Then all of this creates the class architecture in the Android SDK. So now we know how they are organized, how the Android SDK organize things. I think it's necessary to understand what are views for. Actually, views are made for three major things. The first thing is to measure. So basically what we do is we ask the size of each view, and depending on the constraint of the parent. After that, a view is responsible for layouting. So what layouting is to make sure that everything is positioned at the correct place on screen. And finally, when everything is measured, layout, and drawn, layout, we draw things. So this is the three main purpose of the view class. So I wanted to show you a conference that will be happening this afternoon, and Paul, I don't know if Paul is in the room, so Paul is here. He will be talking about this in depth, so please go to making it fit how Android measures and draws view if you want to understand how Android works with that. Because I will try to go further than that here in this conference. So let's go back. So this is the three main purpose of a view. But actually views deals with lots of things. It has lots of responsibilities, such as saving the UI state. So what a UI state is basically the state in which the view, your component, your graphic component is. So let's say that you have a progress bar and you destroy the view, but you recreate the view. This can happen, for instance, if you have low memory on your device, or if you're only rotating the device. Android will destroy the activity and the views, and we'll recreate everything. So this UI state saving happens at the view level. A view is also responsible of managing the drawable state. So I don't know if you're aware of what a drawable state is. It's basically an interaction state. So if you're clicking on touching a button, the button will change its appearance based on the fact that you're touching it. This is what a drawable state is. And the view is also where everything related to events happens. So I'm here talking about touch event because this is usually the most interesting part of events, but there is lots of events such as focus event, hover event, generic events, and of course touch event. And yeah, lots of things like that. So why are we here? Why are you here to develop custom components? Actually, while making these slides, I thought about why do I want to create custom components? And I found four main purposes. The first one, for me, is to factorize things. So basically, it avoids you from creating over and over again the same snippets of code. This is generally something developers like to do because they don't like to copy and paste, or they don't like to do the same thing over and over again. So by doing factorization like this, you can factorize views throughout your entire application, but you can also reuse a component from one app to another very easily. You'll see that later in the session. The second purpose is to speed up things. Basically, in computer science, the less you do, the better. This is more accurate on mobile, of course, because we don't have a lot of CPU, we don't have a lot of memory, we don't have a lot of battery, so please do the less you can. And by creating custom view, you can do that because you will basically flatten your view hierarchy and sometimes completely remove it if you want to, if you draw at the Canva level. So by doing that, you will relieve the system from doing, the passes through the view hierarchy. And sorry, I will talk to that later. And the third purpose is to innovate. So I'm gonna sound like Apple here, but create something unique and groundbreaking. If you start to use the SDK bundle components, you will have an application that looks like everybody else. By creating custom components, you can do something different, something unique that you are the only one using in your app, which will make your app different from the other app on the Google Play. And finally, the fourth purpose is to extend some behaviors that are only available at the view level. So what I'm talking here is, for instance, some state such as the scrolling state. If you want to listen to the scrolling state of a view, you have to inherit it, to extend it, because you don't have a listener at the view level to apply to it so that you can be notified when the scroll has changed. You have to extend it and override on scroll changed. This is the case also for the window attachment state, for instance, when you have on window detach, on window attach, or if you want to listen to the scroll indicator behavior. So now we are over with the definition of all of this. So let's continue with a small demo. So basically what I want to show you is how to create a custom view using Android Studio. So if you don't use Android Studio, please use it. It's a nice IDE that has been announced at the Android I/O this year. So this is now in version 0.1.5, I think. And it's bundled with the new Gradle build system, which is also awesome. So please test it. Even if it's not a final version, please test it, because if you start posting bugs and stuff like that, the people at Google are really happy with that, because it can fix things. So what I'm going to do is to extend. Sorry. So can you see what's written on the? Yeah, it's okay. So what I want to do here is to create a text view that can underline things, which is not possible by default with the Android SDK. If you want to, for instance, have a header in ListView, a great example of that is the setting application. You have lots of headers, to separate things, separate settings. You have a header with an underline beneath, which this is not possible by default. So what you can do is to create a text view that has some additional behaviors, such as the underline. So I've basically called it underline text view, which extends text view because I want to have the exact same behavior as text view, but add some behaviors to it. And what you have to do is to always create those three constructors. The first one is it takes only a context. This is the one that will be used if you create the view via Java code. The second one will be the one that will be used if you create the view via XML. And the attribute set here is actually the thing that bundles all of the XML attributes. And the third one will also be used in XML inflation, but the third attribute is actually the style that you are applying to the view. So now that I have my three constructors, I will add two fields. The first field is a paint, because I want to paint things. So paint is when you want to draw on a canvas, you have to have a paint because it defines the color, the stroke, the width, stuff like that. So I'm going to have a paint, which is obviously a class field. You don't have to, please, it's not that you don't have, please don't instantiate that kind of object in your onDraw method, because if you're doing that, this will be called maybe 60 times per second, because you can run at 60 frames per second. And creating userless objects like that is not necessary. You can do that at the class level. And the second attribute we need is the height of the underline. And now the interesting part is here. So we have two setters. The first one is the set underline height, which obviously check that the client is not too dumb. What is not being dumb is actually to pass something which is not negative. So you have to have an underline height which is positive. And if the underline height is positive, you keep it. And there is a trick here. You use the padding. So you increase the padding with the height of your underline. So why have I chosen to use this trick? Is actually to avoid me to go to this measure pass and stuff like that. I don't like the measure pass. So just by adding the set padding, just by increasing the padding, you'll let the view deal with the padding. But I'm sure that Paul will talk about the measure pass today. And in the set padding, of course, I always increase the padding with the height of the underline. And finally, the thing that we actually want to do is to draw an underline. So everything happens by extending something that is provided by the view class, which is the onDraw method. And in the onDraw method, what I do basically is to call super.onDraw, which is very important if you want to have some text on screen, because if you don't call super, then the text won't be drawn. And finally, what we do here is we check that we can draw the underline, which basically means that the underline has a positive height and its color is not transparent. And we draw a rectangle at the bottom of the view. So this is the custom text view, and how can we use it in our main activity? Just by doing that. We set the content view, so let me show you the content view, which is here. So here is the way to use one of your custom view. So when you're using an Android view, you only use text view, but actually the compiler will replace text view by android.widget.textView, so you don't have to do nothing. It's not the compiler, actually. I think it's at runtime that it is done. And when you are doing custom views, you have to put the entire package name. So here it's com.cyrilmottier.android.customviews.widget.underline-textview. Fortunately, Android Studio has some completion, so you don't have to care about writing all of this. If you're using Eclipse, maybe. And basically what I have here is some layout parents with some padding in the text. Sorry, this was the presentation I made on Friday, so this is not DroidCon, but DroidCon. And I have an ID so that I can grab it from my code. And this, thanks to this ID, I can grab the underline text view, set the underline color, which is a color that I extract from my resources, and the underline height, which is also a dimension that I can get from the resources. So if I start playing with that, so I don't know. So it's using the Gradle, the new Gradle build system here. So you don't have to choose every time the device. You can change it in the preferences. Sorry. So where is my emulator? Here. So this is iOS 7. And oh no, sorry. This is Android. And here is my underlying text view. So sorry for the text, I forgot to change it. So it's hello DroidCon, and below that I have just a single line, which I can change here. So this was the first part. But if you look at that, there's something annoying that you're basically doing some design in your activity, and that's a shame because you have XML for that. So what we can do here is to, sorry, I'm going to check out the second version of the project. If I go back here, now this is what I have. I have only an activity. I'm only setting the content view of the activity, and that's all. And what is this activity? It had some new attributes that are in the Cyril namespace. So how do you use the Cyril namespace? This is simple. You just have to use this line with risotto. Please use risotto because normally you can also use the package name, but with the new Gradle build system, you can change the package name at compilation, and it doesn't change this. So you have to use risotto, otherwise you may have problems if you try to change the package with Gradle. And after that, the only thing I'm doing here is to basically move the code from the activity to the XML. And how have I done that? Well, this is quite simple. You just have to create attributes, a new file, which is attrs.xml. And in this one, you have declare stylable, which is, by convention, the name of the widget. And I have two attributes. The first one is the height of the underline, which is a dimension. And the second one is a color, which is obviously a color. And what do I have to do in the underline text view is to call an init method, which will be called every time. And what I do here is that I obtain the attributes, and I set the underline color and height depending on the attribute that I found in the XML. And please also use this pattern, the try finally, because if you look at the typed array documentation, you'll see that typed array needs to be recycled. So I don't know, maybe you can have a problem in set underline color or set underline height. So always do that in a finally block so that you are sure that the typed array is recycled. And if I play with that, if I run that, sorry, normally I should have the exact same thing, this iOS 7-like looky thing. And that's it. This is exactly the same, but your code is cleaner. So that was basically what I wanted to show you here. So let's back to the keynote. Let me change. I don't want. Yes. So let's go back to the slides. Sorry. So the demo was about underline text view. So now that I've shown you how to create a very basic view, I want to show you how to create something that is different, so more complex. And what I call a completely custom view. What completely custom means? Actually, what I mean completely custom, what I mean is basically extend view or extend view group, because they are the two roots of the view hierarchy. In order to do that, you have to understand how Android does the thing. So I've done something very rapid so that you can understand how Android layouts things and stuff like that. But here again, you can go to Paul conference. So Android does 3 passes to render a view hierarchy. The first one is the measure pass. So you have to measure everything. The second one is the layout pass. So this is done when you call the request layout method. And when you call the invalidate method, the Android will only do the draw pass. So let me show you how it works. So let's say that I have this view hierarchy. So this is a hierarchy like a tree. You have a view inside view. It's inside view. So if you like Inception, it's like dreams, inside dreams, inside dreams. The only difference is that you don't finish in the limbs, or I don't know the English word for that. You finish with a Stack Overflow exception. But please keep it not too deep. So let's say that my text view at the bottom requests a layout. So what it will do is it will ask the linear layout to relayout, which will call its parent to relayout. And the frame layout is the root here in the view hierarchy. So basically, we will start measuring. And the frame layout will ask the linear layout to measure itself, but the linear layout contains some other views, so it will ask its text view to measure itself. And in order to measure itself, it needs all of its children to be measured. So it will then ask to the other text view to be measured. And now that it's done, you can measure the linear layout. And now that the frame layout needs to be measured, it needs the image view to be measured first, and now everything is measured. So this was the first pass. Then the second pass, the layout pass. Now that we have everything measured, we can layout thing. The first frame layout will lay out itself because it knows its size, and then will lay out its linear layout, so its first child, which will in turn lay out the text view and the second text view, and finally the image view. And the draw pass is exactly the same, because you will draw first the view that is the furthest from you. Basically is the one that is the highest in the view hierarchy, so at the root, near the root. But you have to see the hierarchy at the drawing level on the other way around. So basically the frame layout needs to be drawn first. So we will draw the frame layout, which is usually the background, and then we will draw the linear layout, the text view, the other text view, and the other text view, image view. So here you can see that frame layout is drawn, linear layout is drawn, but by default view group does not draw. You have to call a method which has a weird name, which is set will not draw. So double negative, which is completely stupid. I don't know why either. So basically, if you want to draw something, please use a view or a drawable. I've talked about that at the previous conference. Drawables are awesome if you just want to draw, use drawables. But if you want to have something which is more complex with touch events, stuff like that, touch event, measure, layout, and stuff like that, then you have to use a view. But if you just want to draw, please use a drawable because it's lightweight and it draws faster. And it's easier to use, actually, than just a view. So let's start with how it works. So I'm going to be really quick on this, the measure pass and the layout pass. So basically what onMeasure does is it's called by the system when the system wants you to measure your view. So you will have two attributes. The first one is the measure spec. So a measure spec is actually an integer that has two properties in it, which is the size of the parent and the constraint of the parent. And you will have a second attribute, which is the height measure spec, which is exactly the same. So this API is quite weird on Android because basically what it does, it asks you to call a method. And they don't ask you to return something. They want you to ask a method. And this is just to avoid creating a useless object. So instead of creating object, they use the bits of the integer, and they want you to call set measure dimension at the end, so that you can notify the parent that this is your dimension you want. And if you don't call it, this is a contract, then you will crash. So this is the measure pass. Now that everything is measured, you have the layout pass. So the parent will call you, hey guy, I know my size. Now you have to position yourself here at the left, top, right, and bottom properties. You have also a fifth attribute, which is change. I've never used it, but it may be useful sometimes, just to know that you don't have something to do if nothing has changed. So this was the rendering part. But I want to talk about something more evolved, more not interesting, but something that is probably not used enough in Android. So the first thing I want to talk about is state saving, state restoring. So how to save and restore a state. So as I said at the beginning of this talk, you may have a view that requires to save some state, for instance, a progress bar. So a view can have obviously a persisting state. So how do you do that? Well, you just have to create an inner static class. So the static is very important, otherwise you have a reference to the outer class. So you have a static class, which is here called saveState, which extends base saved state. So this is provided in view.baseSaveState. And in this class, you have to implement implement one method and create one field, which is a creator. So actually, baseSaveState is a parcelable, so you have to follow the parcelable contract, which requires you to create a creator like this with two methods in it, obviously, because it's an interface. And the other method is write to parcel. So what write to parcel does, it writes your info in the parcel. So what I do here, I don't know if you can see no. So what I do here is I write a parcel from the parent, because maybe you're using another view, so the parent needs to save its state, and then you write your state, which is here, the progress of your progress bar. So now that you have an object that can be used by the system to save the state of your UI, you need to save it and restore it whenever needed. And this can be done with two methods at the view level. The first one is onSave instance state. So the onSave instance state, as its name suggests, is when you have to save the state. So this is when the view will be destroyed and restored later. So this won't be called if the view is not restored later. This will be only called if necessary. So what I do here is I call onSave instance state on my parent so that it can save its state. I create a new save state with that. And obviously, I'm setting the progress, which is mProgress in my class, to this save state. And I return this save state to the system so that it can save it for later use. And the second part of it is obviously restoring everything. And restoring everything is done with onRestore instance state. So what you do inside, so you have a parcelable. So as I said, parcelable is the object that can be, saved and restored by the system. So it passes, the system passes you the parcelable. You have to cast it. Yeah, this is not nice, but it avoids generics and the use of generics. And you have to cast it in your own save state. You have to restore the state of your parent, and then, of course, you have to restore your own state, which is here the progress state. So that was how to save and restore the progress state. But all of this is useless most of the time if your application does not feel natural. So what does I mean by feel natural is simply reacting to user inputs. So the touch handling part is extremely important to me because this is where I can use, I don't remember which law from Newton is, I think it's the second one. So to every action there is a reaction. So what does that mean? If you start touching the screen, then the views needs to react to it. So how can you do it? Well, you have to use the onTouchEvent method, which passes you a motion event. So what is a motion event? It's basically an object that wraps, it wraps a single touch. I mean, not a touch state, if I may. So for instance, when you touch the screen, this is the first motion event, but when you start moving the screen, the finger on the screen, then you have lots of other motion events. So let me explain you what those motion events can contain. So generally what you do is to switch over the event.getAction, and you will sometimes have the first, when the first pointer went down on screen, you will have action down. So basically that means that the user just started to touch your view. And this is where you will stop any previous animation, of course, because you're touching the thing, and you will start considering this point as the starting of the gesture. So action down is actually called only once, when the first pointer is touching the screen. But if you start having several finger on screen on your view, then you will have action pointer down instead. Then you will have lots of action move. Action moves is when the finger is on screen, but the pointer is moving on screen. And this is where you have to follow the finger. For instance, let's say you have a panel. This is where you will move this panel because you just want to follow the finger of the user. And finally, when the user is over with your widget or with the panel, for instance, you will have an action up action. So action up here again will be called only once. If you start removing lots of fingers, you will have action pointer up. And the last pointer that went up will have action up. And this is where you will have to interpolate the velocity and to do things that will make your object feels like real. And sometimes you can have a special action which is action cancel. So what action cancel is, it's when the parent has intercepted the touch event. So what does intercept mean? So intercept means, what if the parent wants to intercept the view? Or, intercept the gesture. For instance, a great example of that is a scroll view. In a scroll view, you can have a button. So for instance, if you're just tapping on the button, you want the button to be clicked. But if you want to tap the button and then scroll, you want the scroll view to scroll and not the button to be tapped. So this is done by intercepting touch event. And you can do that at the view level, view group level, using the onInterceptEdgeEvent method. So I've added a flag here, which is only for experts only. I don't want to talk about this method. It's quite tricky. Basically, what you have to do is to return a Boolean, and once you return true in this method, then you will send a cancel action to all of the. You will send a cancel action to the view that has the gesture, and you will intercept the gesture and deal with it in your own onTouchEvent and not the onInterceptEdgeEvent method. So if you want to do that, please go to the documentation. This is quite tricky, and you have to understand how it works. So now that we know how to move the object, for instance, the panel, we want to move it so that it reaches the state of rest. A great example of that is when you have a ball. Let's say that I have a ball in my hand. I want to throw it. When I'm not touching it anymore, I don't expect it to throw down or just to stay in the air like magic. No, it's not like that. Nature is not like that. The ball will continue to move until its state of rest. So you have to make sure that your custom components, custom views, looks like nature, looks like something real. So how can we do that? Well, we have to do two things. The first thing is to track velocity. What velocity is the speed of your object. This can be done fairly easily just by doing a single class, which is the velocity tracker. So you can do that, of course, in onTouchEvent. At the beginning of your onTouchEvent, you have this condition, actually, because velocity tracker is an object that can be recycled by the system, so you have to make sure that you don't handle too much on it. So when the velocity tracker is null, I get one from the system, and I always add the movement to it. And at the end, when the action goes up, so when the finger goes up, then this is the time that you can compute the velocity of your finger. And this is done simply by calling .compute current velocity with a magic number, which is 1,000. And 1,000 is actually when you want to have pixels per second. This is the only thing that this 1,000 means. And what I do after that is that I just check that the velocity is greater than a threshold. And if it is, then I start animating the object. So as you can see, I've not decided to use the break at the end of the case motionEvent.actionUp. This is not great. Please don't do that. This is what I decided to use it just because I don't have enough space on my slides. But basically, you have to recycle in both cases. So in action console, which means that the motion event has been intercepted by the parent, then you have to recycle, of course, because the systems may use it, may use the velocity tracker in another view, and you have to set velocity tracker to null. So now that we have the velocity, we need to move things around. And this is done using a class which is the scroller, or more recently, the overscroller. So scroller is available, I think it's in the Android.widget package or Android.view. I think it's in widget, and overscroll too. The APIs look alike. Actually, overscroller has been released pretty recently. It just does overscroll. This is exactly the same as a scroller, but it just overscroll. And this is what is used throughout the system, for instance, in this view and stuff like that. So how do you do that? So once you have a velocity, which is fast enough, then you have to fling. Fling is when your object is moving and reaching a state of rest. And in this method, what you will do is simply call fling on your overscroller. And fling has lots of attributes, so please don't do methods like that when you're developing. Too much attributes, you have to name it with comments. It's usually not good if you do that. So the first two attributes are start X and Y. So this is where you start moving. Vx and Vy are the velocity on the X-axis and on the Y-axis. And finally, min X, min max X, min Y, max Y are the bounds of the movement. So for instance, if you are in a panel, you don't want the panel to slide, like to infinity. And at the end of that, you have to post on animation this scrollable, a particular scrollable, runnable, sorry, that I will show you later. So here I'm using post on animation, which is a new API. I think it has been introduced in API 16. This is great because basically what you ask the system to do is to notify you at the exact moment where the display is ready to display something. So this is called a vsync. So please do that. Otherwise, you can use the compatibility library, which will try to do post on animation whenever possible. And otherwise, we'll simply post with a particular delay. And in the scroll runnable, what I do is every time I'm called, so probably 60 frames per second, I compute the scroll offset, and I use those scroll offset in X and Y to move my object. And obviously, what I do at the end is to repost myself, because if compute scroll offset has returned false, true, sorry, this means that the movement, the gesture or the movement of your object needs to continue. And if it returns false, then the animation is over, so you have nothing to do. So this was how to make sure that everything moves to a state of rest. But this is great, but you still have to be consistent with the platform. You have to make sure that the behavior is consistent with the rest of the platform. And a great example of that is the edge effect. So edge effect is quite new. It has been introduced, I think, in Gingerbread, but it was not called edge effect at this time. It was called, we don't know yet. And it has been released in API 14, I think. And this is what you can see here in the setting apps. This is the glow that happens when you reach the bound of your list. And you can now use it in your own apps when you have the exact same behavior. So for instance, something that is sliding on screen, and when it's reaching the bounds, you want to display this glow. And this can be done just by overriding the draw method in your view. And in the draw method, obviously, you call super.draw, and you have to look at the isFinished boolean written by the boolean written by isFinished on your edge effect. If this is true, then it's not finished, and you have to continue drawing. And you can do that just by doing that. So whenever you draw something on a Canva, you have to save the state of the Canva. You translate it so you draw at the exact same at the exact correct position, and at the end you restore the Canva. And in the middle, what I said is I set the size of the edge effect, and finally I draw it. If the draw method returns true, then the animation must go on, and so you have to call post invalidate on animation so that this is called on the next frame. But that was only the drawing part. How does the edge effect know about the velocity, the fact that you're trying to pull down or to pull up, or absorbing the velocity of your list view, for instance, or your panel? Then you have to use three methods. The first one is onAbsorb. OnAbsorb takes the velocity. That is the velocity when you reach the bound. OnPull is when you are trying to pull down or to pull up or pull right, pull left, I don't know, when you are trying to pull your object. And finally, onRelease is called whenever the finger has been released, when you don't touch the object anymore. So that was the first part, but the second part is to ensure that you have configuration that looks like by configuration, I mean like animation timing, velocity, touch slopes, stuff like that, distances. So you can use the view configuration class. The view configuration class is available, I think, in the Android.view package. And if you look at the documentation, you'll see that it contains methods to standard constants used in the UI for timeouts, sizes, and distances. How you can use it is fairly simple. In order to retrieve it, you just use view configuration, the static factory method, view configuration.get. You pass a context because it needs a context to scale everything up or down if necessary. What I mean by scaling is, let's say that you have a high density display, then velocity will probably need to be higher. And in this class, you can get lots of constances, such as here the maximum fling velocity, which is scaled, of course. You can also have the touch slop and stuff like that. So please, in this class, only use the get scaled XXX methods, because the other methods are not scaled or constants, they are just constants, so they are not scaled to the density of your display. So that's basically the conclusion of it. So in order to conclude this talk, I wanted to give you 3 important things. The first one is custom views are the best way for creating unique UIs, groundbreaking things. So please, please do not hesitate to create something new, something innovating, and something different from what you can find in the SDK by default. The second thing is custom views must fit to the platform appearance. So I know that it's quite difficult to, to innovate, but still keep the appearance of the platform. I don't have tips for that. If you want to do that, you have to do that on your own. Just, feel the essence of Android, feel the language of the design on Android. This is the only way to do things that sticks to the platform but are still innovative. And finally, custom views must match the mental model of the user. A user don't expect a view to stop right now. For instance, if you're throwing an object, a user doesn't expect it to stop instantly. It wants it to move and to reach a state of rest. So please, please, if you're creating custom views, create something natural, something possible in the reality. And I think that's pretty much it. So thank you very much for being here. So the slides will be available, are already available on my speaker deck. So go to speakerdeck.com/Cyril Mottier and you'll find these slides. So if you have questions, I don't know if we still have some time for questions. Yep. So please go ahead. I think no. No questions? That was clear? You are the best developers on earth. Yep. Well, I can repeat in English, or you can do that in French if you want to.
Thank you very much for this presentation. It was very deep insight a few problems. One problem we often meet when we create applications is to have a clear set of criteria to distinguish what should be a view and what should be a fragment.
Yes. Yeah, I think this is something that has been introduced with the release of fragments. Actually, fragment for me is like a controller. Sorry, so the question was, we have a problem understanding what should be a view and what should be a fragment, sorry. So for me, a fragment is more like a controller. It's not, it's like a small activity that manages a view, but basically a view is only, you must use a view if you want to measure things, lay out things, draw things, manage a touch event, stuff like that. You can't do that at the fragment level because it's not made for that. It's only made for being a small activity that is tied to the activity lifecycle. Is that a great response, answer to you? Thank you. Maybe you can talk about that later. Other questions? I still have one. Yep.
Est-ce que vous avez sur un site, je sais pas, quelques exemples de belles custom views, parce que là on a vu un exemple très simple, mais pour montrer l'intérêt d'une custom view, voir parfois des gens très forts qui sont capables de faire des custom views vraiment jolies.
Oui. So the question was, is there, I don't know, a web page where you can find lots of examples of custom views? Actually, there is one, which is source.android.com. You have lots of views in it. So I've, I said that the Android bundled view are not great, but actually they are great if you want to learn how to use things. I've learned everything just by looking at the source code of Android. And after that, if you want to learn new things about how to create custom views, then I highly suggest you first to go to the Android source code, and then to go to GitHub, because there are lots of custom views. For instance, you can find a view pager indicator from Jack Walton. You can find the sliding panel. You can also go to the source code of the Android support library, where you can find the navigation drawer, the new drawer, I don't remember the name, but the drawer in Google Talk, Hangout, sorry. So please, you can go to GitHub and you will find lots of custom views like that. That's it. Thank you very much. Your turn. Par contre, je reprends mon chargeur, ça te dérange pas?
Non, ça me
Ah bah de toute façon.
pas.
T'es pas venu avec un Chromebook Pixel? Mais c'est quoi?